Okay, everyone, we're going to start the next session here. So now in our final talk before the lunch break, we'll have Harald Wuest from Visometry telling us about quality inspection in AR. So Harald Wuest, CEO and Managing Director at Visometry, the German deep tech and AR solution startup known for its VisionLib engine, which is the basis for a wide range of augmented reality applications that require high-performance object recognition and precise tracking. As one of the co-creators of core AR algorithms, including model tracking, Harald is not only an AR expert and tech inventor from the very beginning, but a strategical and analytical mind who likes to push boundaries of current AR technologies to enable industries to bridge the gap between virtual and real for safer and more efficient workspaces. So give it back to Harald.
Yeah, thank you very much for the introduction. So, we have been in the augmented reality space for quite a long time. So we are located in Darmstadt, Germany, which is central Germany. We are a team of 25, meanwhile, people, mostly experts in computer vision and augmented reality. And our core system is a model-based tracking system. And we have this out on the market for 6 years now. So it was first released at the AWE Expo here in 2017, where we showcased the very first version of this SDK. And we continue to work on our core technology, where we addressed augmented reality developers. But of course, many people ask us, hey, what can I do with it now? And so we also thought, okay, what are the interesting use cases for this tech, and how can we make this technology more valuable? And so just a quick presentation of the idea of this model-based tracking is that we take any kind of 3D model or 3D mesh data, and our computer vision core system is able to detect this in any kind of camera image. And this is then the core of our model-based tracking engine, addressing any kind of augmented reality device, mostly platforms like iPads or Android, but also HoloLens or other glasses. And so we have been, me coming from an applied research institute, which is more technology-driven. We first had the technology, and we were asking what is interesting use cases? What can you do what can you get out of this technology where you are able to have this direct connection between 3D space and the physical world? And so, of course, enterprise customers are an interesting thing because of the direct connection to the 3D CAD world. And there are many use cases like training, maintenance, repair, quality inspection, field service, or marketing. Today, I want to focus more on the quality inspection part, because this is a use case we investigated, has a very high value in the whole value creation chain for different kinds of industrial augmented reality applications. So for giving you a short overview about different kinds of enterprise augmented reality applications. So here we have an overview, what lots of market research institutes promote. So there are different use cases like step-by-step instructions, training, or remote assistance has always been a very wide industrial use case, maintenance and data capture. But quality inspection was never such a big, there was not such a big focus on this very special use case. But I guess in the future there will be lots of industrial revenue being spent in that space. So just some examples of industrial applications using model tracking technology, where the 3D model is the reference of any kind of augmented reality applications. Here, a marketing use case we did with our tech, where an application is used to showcase certain features of here, the car, and to make it easy for potential buyers to understand the technology and to give them more insights into how this tech works. Or also training is always a very interesting case where augmented reality is used to transform knowledge to people who want to know how this machine works or how to maintain this machine, so that they don't have to read manuals, but like get a quick overview, like how to do certain tasks to maintain this machine. An evergreen in augmented reality is like maintenance and repair. So this was, in fact, one of my very first projects, like in the top 2 images with BMW. This was 2004, where like the very first version of this augmented reality-based maintenance applications were done like more in a very, very experimental stage. And yeah, so these were the first steps, but like both like the tracking technology and also the content creation have been, of course, improved a lot since then. Another example regarding maintenance here from Scope AR, who use also our tech. They have a very great system for creating like the work instructions and creating like contents for maintenance. Another example of other partners of ours, they use this like more for consumer products. Here, like a coffee machine is also always a good example, because many people, if you have a new coffee machine, so many buttons, you don't know what to do and where to press to get like the coffee how you like it. So this could be definitely interesting and always helps people. But of course, it's always the question, what is really the value? Is the effort you put into these systems really that valuable that there's like some benefit at the end of this system? So it takes a lot to scale these applications, because especially what you need is like lots of authoring efforts to create this content, to use it like all the tools and tool chains, and to create like a comprehension concept to transfer the knowledge what you want to give to the user of the augmented reality application. And so it's hard to automatically scale these applications. So typically for the workflow in industrial applications, there's always some data like technical drawings, videos, or like documents where there's like this information which you want to put into like the augmented reality space. So this is like always a big task to convert this data into information which can be used in augmented reality. And of course, there are lots of helper geometries like animations, 3D arrows, or indicators which point out certain tasks. Then the tracking is also like you need to put effort into setting up the tracking. Sometimes you need to prepare the scene with certain references so that you're able to localize your augmented reality device within that scene. And then the delivery, not every augmented reality device can be used for any jobs. For maintenance, of course, you need like a hands-free device to carry out like the tasks. And then like in the interactive viewer, like a presentation might not match always to the reality. So these are like the challenges for these enterprise use cases. And the biggest challenge is always like the content. So yeah, content is king. Creating this content is like always a big task to get the application really running in a productive way, and to roll it out like on the shop floor. And so many companies also focus like on this content creation pipeline to create like solutions to make this content really simple. But of course, it's still like effort to get things running and to scale up and roll out these applications. So it's lots of effort, and there's always the question, is there really benefit? So for example, we also created like an application for a customer where we did like a step-by-step maintenance instruction to repair certain kinds of machines. And we also did like a fallback mode within our augmented reality application, which is mostly like where only the 3D model in a virtual reality kind of environment was shown. And at the end, we carried out these tests with people doing like these maintenance tasks. And it turned out that they were completely happy with only looking at the tablet with the 3D data, and the need of putting the tablet pointing to the machine where they get like the instructions like switch on this switch and put the cable into that plug. They really didn't need this, so they could carry out the whole task by just looking at the 3D model and then doing this task. So there was no real benefit putting these instructions into AR because it was good enough in VR. So now I want to switch to this quality inspection use case. So what's different when you do like quality inspection? So typically, this use case addresses the problem when a quality engineers wants to detect like differences between like a virtual 3D model and like a physical part. The big benefit is that the CAD model itself is already the information and is like the content itself, which makes things like way more easier and way more direct to scale. So here to give you like an overview about like these quality inspection use cases. Here, this is like part of our solution. So where like a quality engineer goes around like a certain welding structure and uses like a tablet to look at that part to identify differences between like the virtual CAD data and like the physical part. And there he can quickly identify like differences where like holes or bolts are like not welded correctly. And like especially for like use cases or like for manufacturing industries which produce parts in like low quantities with high variations, these augmented reality applications are very, very useful because they are very easy to apply and can be directly used like on the shop floor anywhere. So that's the idea of this industrial augmented reality application. And when we look here at the challenges, we have also like the data. The 3D CAD model, of course, they need to be there, but most of the companies who produce any parts, they're all constructed in 3D CAD these days. Regarding the content, we don't have to create lots of content because like the content is already the 3D CAD model, and for the tracking, we can also directly rely on the 3D CAD model. So we don't have to do any preparation regarding the tracking, and we don't have to do lots of preparation regarding the 3D content. Of course, when there are like checklists and we want to like a step-by-step instruction, we can also put like some manual effort into like a guided process, but at the end, the content is already there. So with this idea, it makes it really easy because the effort on rolling out this application is much less, and so it makes these quality inspection use cases like a good case with like a proven return on invest of the whole application, because like not much effort needs to be done to scale the system. So typical users of these industrial quality inspection use cases, they have to work with data and have to put like effort in like this job preparation. For example, for manufacturing frames, people build like these stencils, like these big metal stencils to check like if, for example, assembly frames are really built in that way. And this is also like lots of preparation to be done to carry out like these inspection processes. One task is then, of course, carrying out this inspection and also like the documentation and the circulation of this documentation result. Like an augmented reality solution for this industrial quality inspection process is like much easier because like the data preparation can be done fully automatically if you have like a file of 5,000 3D models. You don't have to prepare a lot, and it can be completely automated within a system. And the inspection process can be done like mobilely. It's like very easy to apply if you just have to carry out like an iPad on the shop floor. And while you have an iPad, it's also like already there that you can use your camera to take pictures and document like the whole quality inspection process, which is also like a part within like the whole digitization of production industry. So this is why like these quality inspection use case provide like lots of value. So we looked at many of these industrial use cases, and this is why we decided to go vertical based on our core tracking technology in this area of this quality inspection, because we saw like the biggest value which could be created in this use case, and also the biggest potential to scale like these applications. So here I can give you like an overview how this works. First, we have like the model preparation. This is like a part of the Twin Studio software, which is like a desktop software to import the 3D CAD data and set up like these inspection processes. So when you only want to take this 3D model, you don't have to do much, just like import the data, and like your your project might be ready already. But you can also, of course, define like a step-by-step instructions to do like a guided inspection. For the tracking, we rely on our VisionLab SDK, where we use like the 3D mesh model, and which can then be used as referencing these 3D parts without any preparation stage, without any model target learning or anything. So like with a very direct connection to the 3D CAD world, so which makes it also possible to, if you have like thousands of models, you can instantly use them to detect them in these camera images. When carrying out these inspections, we have like this mobile augmented reality application, and this now can be used to go through the inspection process step by step, document like differences between virtual and the physical models, and create like an inspection report where like all these differences are documented. And like years ago, people always had like these paper-printed checklists where they went into the shop floor and used like this checklist to go through all these checks, and this was of course lots of effort and also prone to lots of human error. If you have this like in a mobile app, of course this data can be processed way easier, and of course you can also carry out like way more inspections because it can be done much faster. So yeah, I just talked about this documentation process. At the end, there will be like a digital report, which is then used to further for the quality system of any production facilities. So here we see this in the bottom window. So let's like find the final end result, which is then like the output of this system. So since like we were a computer vision company, we have lots of expertise like in computer vision. We also want the computer vision not only to be used to align the virtual model, but also to assist like the quality engineer. And there's lots of potential using this also to automatically inspect certain parts. So the first feature here is that we use the model tracking and not only check like one model, but like multiple models independently of each other, and we are also able to check like the existence of certain subcomponents of the models, if they're at the correct position or if they're like existing at all. Here's like another example where like welding spots or like bolt holes are automatically inspected based like on the 3D CAD data. So in the 3D CAD data, there we have like the exact position where like these bolts, for example, need to be located, and it's like an easy process to just select them all and put them into like the quality testing step to check if they are like at the correct position or in the correct space. They're like within this quality inspection area, like different applications which can be addressed. Like one is like body in white inspection, to check like if all geometric features of this body frame are at the right place, such as these welding points or bolts, and to check if this is like proper manufactured for the so that there are no crashes like in the further manufacturing process. For these big parts, it's especially useful to have like a mobile system, because these are big welding structures for construction machines, and by using mobile applications, you can just go out on the shop floor like anywhere at any time within the production process and check like if parts like are correctly assembled, like if all holes or other parts are like correctly in this stage. And this, of course, provides lots of value, because it can be carried out within minutes, and you don't need to you need to use other costly measurement devices, and only using like a consumer hardware is kind of cheap, in relation to like these complex metrology devices. Tool making, here we have like an assembly frame which is used for creating tools for manufacturing processes. And of course, when these tools are not correctly configured, there will be some crash later on in the assembly process. And by using like an augmented reality solution, it is also very easy to compare if like this tool has been configured in such a way that it is like useful for the task in the manufacturing process. And yeah, this is like an example where like these mechanical stencils have been used before, and of course this is lots of preparation effort, but if it's just used like with an AR system, it's an easy thing. Like last but not least, like incoming and outgoing goods inspection for suppliers, like the OEM is taking a 3D model, using taking a part from suppliers. He wants to check this, and of course the supplier wants to check this because before it goes to the OEM. And of course lots of money can be saved when they only send like the correct parts out on the road. Here's a statement of our one of our customers. They build like agricultural machines, and yeah, they have been like our first users of our system, and yeah, they have been using this now like for 2 years, and yeah, quite happy about the outcome and the ROI what they achieved with the system. Yeah, so to wrap it up, like from all these industrial use cases, like we got like the best ROI on this quality inspection use case, because there's lots of value by digitizing these industrial inspection processes, and there's lots of increase in speed and also quality, and lots of reduce in costs, so with a proven ROI. So we also have a booth here. If you have any questions, we are happy to answer you that now. And yeah, so if you like to visit us at our booth, we are happy to get in contact with you. So yeah, that's it. Thank you very much.
Okay, if anyone has any questions, we have time for about 1 or 2 questions. If you can come up to the mic.
Thanks for the talk. I was just curious, I saw that most of what you showed, they were using a tablet. Mm-hmm. So do you also support wearable headsets like the HoloLens, the Magic Leap 2?
Yes, like on a technical point of view, like our VisionLab SDK also supports like HoloLens or Magic Leap 2. Regarding the quality inspection process, we more focused on tablets, because they are just easier to use on an application side. Because if you have to press buttons or write some text or make some annotations, tablets are easier to use. Like for the inspection process, you don't need the hands-free, and tablets are just devices everybody knows how to handle. So we more focused like using tablets for this application, because they're just like more handy and less complicated to use on the daily basis.
Thank you.
All right, we are out of time for this particular session, but remember, you can always visit their booth at the expo. If we can thank our speaker one last time.
Thank you.